Hello, how you doing today? Today we'll be talking about the periodic table. So I will be introducing the periodic table to you. It's very important that you understand the periodic table if you want to have a very good understanding of chemistry. If you have problems, if you have had problems with understanding chemistry before now, all right, and chemistry looks like magic to you, I want to let you know that the reason is very simple. And the reason is because you do not have a comprehensive knowledge of the periodic table. Because most of the things you do in chemistry, you'll be dealing with chemicals, chemical compounds, compounds are formed when two or more elements are chemically combined together. And the way you understand the periodic table, which shows the arrangement of those elements and how they behave, when you understand that periodic table, a lot of things that looks like magic to you in chemistry will actually be much simplified for you. So today I'm going to give you a brief breakdown of the periodic table. I want to encourage you, make sure you watch this video to the end so that you can actually have a good understanding of the topic of discussion today. Now, when we talk about the periodic table, we are talking about the table that shows the arrangement of elements based on their similarities. Okay, so they are arranged into different families based on their similarities. And then basically there are two types of arrangement of elements on the periodic table. Now before I talk about those two arrangements of elements, and remember I'm going to give you shortcuts as well that you can use to remember a couple of things on the periodic table, and that is why you want to stay tuned to watch this video to the very end. All right, Dmitry Mendeleev is believed to be the father of the periodic table because he was the one that came up with a table that perfectly arranges or shows us those arrangement, the arrangement of elements based on their similarities. All right, now you have about 118 elements on the periodic table, and for you as a beginner in chemistry, or you that you're not so much versed in chemistry, you are not actually expected to bother yourself trying to master all of the 118 elements. And that is why you have a representative table. The representative table is just a table that shows you the arrangement of the first 20 elements. So when you understand the first 20 elements, you understand how they behave on the periodic table. That is exactly how the 118 also behave on the expanded, on the complete periodic table. So I'm going to be using the representative table, all right, which is showing the first 20 elements. I will use that to explain the periodic table to you. And if you understand that, then you can just transfer that knowledge to the complete periodic table. All right, so come with me. Behind me is the representative of the periodic table. Now, if you look at the complete periodic table, you have about 18. You have 18 groups and periods. So let me start by telling you what groups and periods are. I told you earlier that elements are arranged on this periodic table based on their similarities. So elements are actually arranged on this table in vertical columns and horizontally. All right, so the vertical arrangement is what you call the groups. So groups, elements are arranged in groups and periods. The groups are the vertical arrangement. All right, vertical arrangement of elements on the periodic table, that is the group, while the periods are horizontal arrangement. Horizontal arrangement. So for these groups, which is the vertical arrangement, you have arrangements in columns. Columns. So this is a column like this from up to down. This is the vertical arrangement, and this is the horizontal arrangement. So when you stand, if If you stand like this and you raise your hands up, so this is letter V, alphabet V. So this is vertical. And then when you spread down your hand, make it straight like this. This is horizontal. So this is horizontal and this is vertical from up to down. And there is an acronym I've given for you to easily understand. VGC, to easily remember which is the vertical, which is the horizontal, VGC and PH. So what does VGC stand for? VGC means groups are vertical in chemistry. Groups are vertical in chemistry. Why PH? You know, PH is Port Harcourt, but in chemistry it means periods are horizontal. Periods are horizontal, while VGC is groups are vertical in chemistry. Now, when we talk about groups, they are vertical arrangement. So these are the vertical arrangement. So in the complete periodic table, we have 18 groups. 18 groups. Are you with me? However, in this abridged version, we have just 8 groups. So there are 8 groups on this table. And then you have 7 periods. 8 groups and 7 periods, okay? So, but for the first 20 element, we will not be looking at the 7 periods, we'll just be looking at 4 periods. So, can you see this is the group? You have the group 1, group 2, so I can put an arrow here, alright? This is group 1, this is group 2, group 3, group 4, group 5, group 6, group 7, group 8, or group O. Alright, and then we have the periods. This is period 1, period 2, period 3, and period 4. So, vertical arrangement is referred to as the group. So you have the group 1. The groups are written in Roman figure. This is group 1, 2, 3, 4, 5, 6, 7, 8. And the period, this is period 1. So everybody here is in period 1. All the elements here are in period 2. All elements here in period 3. All elements here are in period 4. Now let's take a look at what are the members of the group. What do they have in common? You see that members of this group, they have something in common. What exactly do they have in common? This is group 1. Everybody in this group, they have 1 in common. So before we look at that, can you see I have a number written at the top of each of these elements, these symbols. I have number 1, number 2, number 3, number 4, like that, number 10, 11 to number 20. Those numbers are called atomic number. Alright? They are called atomic number. And what is atomic number? Atomic number of an element is the number of protons present in an atom of that element. Let me repeat that. I said atomic number is the number of protons present in an atom of that element. So that means an atom of hydrogen has 1 proton in it. An atom of calcium has 20 protons in it. That's the atomic number. And that atomic number determines the position of an element on the periodic table. So calcium is occupying position number 20 because the atomic number of calcium is 20. Hydrogen is number 1, its atomic number is 1. Sodium is number 11, atomic number 11. And so the number of protons in sodium is 11. I hope that is clear. And then the number that I have at the bottom, I'm going to be using all these numbers to explain this table to you. So these numbers that I've written here is what you call electronic configuration. What is the meaning of electronic configuration? It's just the arrangement of the electrons in the shells or the orbitals of each of these elements. So if you look at the structure of an atom, all right, the structure of an atom is something like this. You have inside, there is a small hole. If you look at an atom, this inside is called the nucleus. The nucleus of the atom, while this outside is called the shell or the orbital. The shell or the orbital. Orbitals are where electrons are found. So electrons are found on the shells of the orbital, while in the nucleus there are 2 particles inside this nucleus. The first one is the proton. Alright, proton is found inside the nucleus, and the second particle here is called the neutron. Neutron. Protons are positively charged particles inside an atom of an element. So you remember we said the number of proton is the atomic number and it determines the position of that element on the periodic table. So protons are positively charged. While this neutron, what charge is the neutron carrying? Okay, you said negative. No, that is wrong. Then some of you said neutral. That is also wrong. Neutrons are not carrying neutral. Neutrons are carrying no charge. No charge. No charge. No charge means neither positive nor negative. So neutrons are neither positively charged nor negatively charged. So when you say neutral, neutral means equal positive and negative. So when a substance has equal positive and negative charge, you say it's neutral. But for neutrons, it is not having negative charge, it's not having positive charge. So it's neither of the two, therefore it's called neutron, no charge. And then you have the third particle that makes up an atom, which is the electrons. So these are the electrons. And remember I told you electrons are found on the shells or the orbital. So these electrons, they are negatively charged. They are negatively charged. So come with me. Now, these electrons, even though they are present in these atoms, they are not all piled up on the same shell. And that is the meaning of electronic configuration. They are arranged into different rooms. Are you with me? So, for example, potassium has 19. So let me also say this. You know, I told you this is the atomic number, which is the number of protons. But you also need to understand there are equal number of protons and electrons. There are equal number of protons and electrons in an atom of an element. Let us note that. I said there are equal number of protons and electrons in an atom of an element. So what does that mean? What that means is that in an atom of any of these elements, there are equal number of protons which are positively charged, and then there are the same amount of electrons, negative. So sodium has 11 protons and it also has 11 electrons. Hydrogen has 1 proton, it has 1 electron. Calcium has 20 protons and it has 20 electrons. Are you with me? Now, but these electrons, because the electrons are the ones that take part in chemical reaction. Like you can see here, the proton and neutron are inside the nucleus, so they don't get to react in chemical reactions. They are just there, they don't change. Alright? It is only the electrons, and not all electrons take part in reactions. It is only the electrons in the outermost shell, which you call the valency. The electrons in the outermost shell, they are the ones that take part in chemical reaction. So this arrangement that I have these numbers, they are called electronic configuration. That means the arrangement of electrons into shells. So lithium has 3 electrons, but the arrangement is 2-1. For beryllium 2-2, boron 2-3, like that. Fluorine 2-7, neon 2-8. For sodium 2-8-1, and it continues like that. Chlorine 2-8-7, 7 electrons, but they are arranged in this manner. And then potassium and calcium. So now let's talk about groups and period. I told you earlier that groups are vertical arrangements of elements. Now members of this same group, what do they have in common? They have the same number of electrons in their outermost shell. Alright? They have the same number of electrons in their outermost shell. Vertical arrangements. Vertical arrangements of elements on the periodic table. So what do members of the same group, what do they have in common? They have same number of electrons in their outermost shell. And that is what you call valency. You call it valency or valence electrons. Valence electrons are the number of electrons in the outermost shell. So members of the same group, they have the same valency. They have the same number of electrons in the outermost shell. That is number one. What else? Members of the same group, they have similar chemical properties. So they have similar chemical properties. They have similar chemical properties. And because they have similar chemical properties, they take part in similar chemical reactions. So they have a lot of things in common. For example, if you look at this group 1, hydrogen is the only element that is different from the rest in this group. Every other element here, they have something in common. Alright? In terms of their chemical properties. All of them are metals except hydrogen, which is gaseous, right? Which is a gas. But the reason why hydrogen is positioned here and is not positioned anywhere else is because of this valence electron, just one electron. So hydrogen is the only non-metal in group 1. Every other element in group 1, they are metals. And because it's a gas, we cannot position it on this group because it has not attained stability. It has not had 2 or 8 electrons in the outermost shell like the guys in this group 8. Helium already has 2 and every other person here already has 8. Alright? So hydrogen cannot belong there. It is also worthy of note to understand that every of these elements, they want to try to be like the group 8 element. They want to have 8 electrons in their outermost shell. We are going to see that as we progress. Okay, that is what we make them to take part in the reaction. So the reason why they take part in the reaction is because they want to have 8 electrons in their outermost shell. So I've dealt with group 1. I said groups, they have vertical arrangements of elements. They have same number of electrons in their outermost shell. They have similar chemical properties, and by that reason, they take part in similar chemical reaction. So any reaction that sodium can take part in, potassium can take part in it as well. And then you have some other elements in the period 5, 6, 7. I told you have 7 periods there. So you have rubidium, you have caesium, you have francium. Those are the other elements that make up the group 1 element. Rubidium, yes, francium, then caesium. Or sorry, rubidium, caesium. This is it. So you have rubidium, caesium. Caesium is different from calcium, so do not mix it up. Alright? And then you have francium. So those are the, if you look at the complete periodic table, those are the elements that complete the group 1 elements. So, because members of the same group have the same number of electrons in the outermost shell, can you see here they all have 1. Group 2, they all have 2 in their outermost shell. If you look at group 3, they all have 3 in the outermost shell. Group 4, they have 4 in the outermost shell. Group 5, they have 5 in the outermost shell, 6 in the outermost shell. Group 7, they all have 7 in the outermost shell. And then group 8 or group O, they are called group 8 or group O, they all have 8 in the outermost shell except for helium, which has 2. Because the shell, the first shell that helium has, the maximum number of electrons it can carry is 2. And that's why can you see 2 before 8, 2 before 8 is. So the first shell has to be filled with 2 electrons. Alright? And that is that. So then when we talk about period, now periods are horizontal arrangements. So what are periods? Periods are horizontal arrangements of elements on the periodic table. So these are arranged in periods. And what do they have in common? Can you just inspect and tell me what they have in common? They have something in common. Now this is what they have in common. Every member of this group, they only have, of this period rather, they have just a single shell. Remember I told you electrons are found on the shells. And I told you these are called shell electronic configuration, the arrangement of elements in the shell. So members of the same period have same number of electron shells. They have the same number of shells. What does that mean? So let's look at this. This is just one shell. This is just one shell. This is two shells. So let me make it clearer that you can easily relate to it. Everybody here, they have 2-bedroom flats. Okay, 2-bedroom flats. Everyone in period 1, they have just a single room self-con. Single room self-con. These guys, they are all having 2-bedroom flats. These guys are big boys, all right? So they have 3-bedroom flats. Can you see? This is the first shell, this is the second shell, this is the outermost shell. So all of them here, they have 3-bedroom flats, 3 shells. And then these guys are having 4 rooms, 4 shells. So members of the same period, they have the same number of electron shell. Is that all about members of a period? No, that is not all. So what else? What else do we have to say? Look at it. Their atomic number increases progressively across the period. Also, their valence electrons increase, let me use successively, across the period. What does that mean? So you remember I told you this number at the top is called atomic number. So here this is 3, 4, 5, 6. So the atomic number is increasing across the period. That is the meaning of this. Atomic number increases progressively. And then for their valence, what's the valence electron? I told you valence electrons are the number of electrons in the outermost shell. So sodium has 1 valence electron, 2, 3. Can you see that their valency is increasing? 5, 6, 7, 8. So their valence electron increases successively across the period. So those are the things that you need to know about members of the same group and members of the same period. Now, with that being said, let us look at we'll try to look at the names, okay? So I would now look at this. Group 1 to 3. So elements on this table, they are divided into 3 broad families. And those are metals, non-metals, and metalloids. Metals, non-metals, and metalloids. So group 1 to 3, they are metals. So group 1 to group 3 of this table, they are metals. They are called metals. Group 4 are called metalloids or semi-metals, and group 5 to group 8 are called non-metals. So on this table, group 1 to 3, they have certain properties in common because they are all metals. Alright? While group 5 to 8, they also have something in common. They are all non-metals. Then, so this is group 5 to group 8. They are non-metals. Then this group 4 at the middle, they are called metalloids or semi-metals. They have some characteristics of metals and that of non-metal, so they can combine, they can act both as a metal and a non-metal. So before we look at those characteristics, and then, yes, I've done a video on periodicity, the periodic law, the periodic table. If you have not seen the video, you can check the video up there. There's a link up there, or you check the description, you will see the video to periodic properties and periodicity, how those properties increase and decrease across the period and down the group. So, but let's continue with this. Now, these group 1 elements are called alkali metals. So group 1 elements are called alkali metals. Example of alkali metals are lithium, sodium, potassium. Then group 2, they are called alkali earth metals. Group 2 are called alkali earth metals. Now, let me say this before I go to the non-metals. If you look at the complete periodic table, between group 2 and group 3, there are 10 groups. Between group 2 and 3, there are 10 groups. Those 10 groups are called the D group or the D block. Elements in the D block, they are also called the transition metals. So they are also metals. They are in between group 2 and 3. But because these are abridged, or this is a smaller version, this is a representative of the complete table, alright, that is why we have this. For the first 20 elements, none of them is in the first 20 elements. But just take note that between 2 and 3, you have 10 groups which are called the D block element. So this group 1 and 2, they are the S block, alright? Group 1 and 2, they are S block, S block, S block in the sense that if you write the SPDF configuration, you will see that they are only made up of the X block. They are found in the S block. So between group 2 and 3, you have the D block, which are 10 groups. And then from group 3 to the group O, they are the P block. And then you have another fourth block, which is the F block, which are underneath the complete table. They are drawn from somewhere around here, but they are drawn, if you check the complete table, you call them the lanthanides and the actinides. The actinides and the lanthanides, they make up the F block. But that is not what we are looking at for today. Alright, I have a video on that on the complete table. You can check it out. But for today, you need to understand this first. So this group 1 are called alkali metals. Group 2 are called alkali earth metals. Then you have the group 7. Group 7, they are called halogens. Halogens. These halogens are very, very reactive. Alright, they easily accept electrons. And then you have the group 8 or group O, which are called the noble gases, rare gases, or inert gases. So they are noble, rare, or inert gases. The meaning of inert means they are inactive. So elements here are inactive. Why are they inactive? I told you earlier that all the elements on the table, alright, they want to be like the group 8 elements. They want to be like the noble gases. The noble gases don't take part in reaction because they have already attained 8 electrons in their outermost shell. They already have octet valency, 8 electrons in their outermost shell. So because they have attained 8 electrons in the outermost shell, which is stability, they don't take part in chemical reaction. So every other person wants to behave like the noble gases. And then that is why they take part in reaction. They either give out electron, accept electron, or they share electrons. And so let us take a look at how, let's see the application of the knowledge of this periodic table. Now, everybody in group 1, they have 1 electron in their outermost shell. How many do they need to have 8? They need 7. They need 7 electrons. Now, there are 2 options. They are either going to accept 7 electrons or they give away 1. So there is this illustration that I will use for you. Alright? Which is easier? The child of a goat is called kid. Now, I like to give keys to my students so that these things can be very, very easy. They can easily relate with it. The child of a goat is called a kid. So if a man goes into the street and begins to kidnap, you want to kidnap 7 kids, not human beings, children of goats, okay? And then he picks the first, picks the second. Before he gets to number 7, what do you think will happen to that man? He will be arrested and he could be given serious beating, arrested, handed over to the police, or jungle justice, which is bad, okay? So, which is very risky. So, it's risky for him or for these guys to kidnap 7, but it's easier to give away 1. All right, can you see potassium gives away 1, and then now as it attained 8, yes, it now has 8, so it is easier for them. Therefore, this group 1, they take part in chemical reaction by giving out electrons. All right, so when they give out electrons, they become, when they give out electrons, they become stable. All right, they have 8 electrons in the outer shell. They have attained octet. Octet valency. Octet valency means they have 8 electrons in their outermost shell. Let's go to group 2, magnesium. Kidnap 6 or give away 2. Which one is easier? It's easier to give away 2 than to kidnap 6. If you come to group 3, kidnap 5 or give away 3. It's easier to give away 3 than to kidnap 5. So, but if you come over to group 7 here, so we are going to look at what is happening here. So, these metals, group 1 to 3, they take part in the action by losing electrons. They lose electrons or they give out electrons. So, metals, they take part in chemical reactions by losing electrons. So, when they lose electrons, they become positively charged. Lose electrons to become positively charged. Because givers are positive, borrowers are negative. So they give out, and then when they give out electrons, they lose electrons, they become positively charged. This is exactly why your sodium, I know you would have seen stuff like Na plus. How come we are having Na plus and not Na minus? We cannot have Na minus because sodium always gives out, and it will give out 1 electron. So your normal neutral sodium elemental stage, this is what you have. But by the time this sodium gives out 1 electron, it becomes Na plus. So it's carrying positive charge. The meaning of that positive charge means it has given out 1 electron. Sodium will never be Na2 plus because it does not have 2 electrons in the outermost shell. But let's take calcium for example. At the neutral stage, calcium has of configuration 2882. But by the time calcium gives away these 2, Ca2 plus, it will now be 288. Can you see that it has now attained stability? So they take part in reaction by giving out 2 electrons. That's members of group 2. While members of group 3, they give out 3 electrons. That is why your aluminium will become Al3 plus. Are you seeing it? That is why aluminium becomes Al3 plus, because it's going to give out 3 electrons, not 2 plus. 3 plus because it has 3 electrons in the outermost shell, and those are the guys that take part in chemical reaction. So let's consider the non-metals. Let's consider the non-metals. For the non-metals, they take part in chemical reactions by borrowing electrons. So let me give you this illustration so that you can easily remember, recall, and you can apply. If you have a dog, in your compound, maybe a German Shepherd, you have an idea of how much a German Shepherd costs in Nigerian currency. So let's assume you want to be conservative. Call it 100,000 Nigerian naira for 1 German Shepherd puppy. It could actually be more than that. So if you have an idea of how much it is in your own around you, you can go to the comment section and just put the cost there. All right. But then we are trying to learn something here. Now you have a dog, and then that has puppies. All right. Your dog has 7 puppies, and you already have prospective buyers that are ready to pay 100,000 Nigerian naira on each one. And that is 7 puppies, that's 700,000 naira. And then you're already happy that, oh, I'm 700,000 richer. And then one Saturday morning, your dog goes out to the street to exercise. because of the fat, the weight in the body, they want to burn some weight. So the dog goes out to the street on the Saturday morning with the puppies, with 7 puppies. And then by the time the dog came back to your compound, the dog came back with 2 puppies. Would you be happy? You wouldn't be happy. You'll be mad at the dog, right? Why? Because he has thrown away 5 out of 7. And then now 500K, 500,000 gone. So it is easier rather than throwing away these 7, because these guys, they have 2 options: either throw away 7 or do corporate begging for 1. So instead of throwing away these 7 electrons or 7 puppies, this guy will rather do corporate begging for 1. That is why all these elements in group 7, they take part in reaction by borrowing electrons. So they won't give away the 7, rather they will borrow. And they are called halogens. So group 7 are called halogens, and they are highly reactive. They are very reactive. Why are they very reactive? Because if you want to come and take from them, they won't give you. The electron that you have, if you don't hold it tight, they can grab it from you. So they are very, very ferocious, all right? And then they are highly reactive. And that is why group 7 is the most reactive group. All right, and fluorine is actually the most reactive element. No. If you come to group 6, they need 2, which is easier to do corporate begging for 2 or to throw away 6 puppies. It's easier to do corporate begging for 2 than to throw away 6. So that is why oxygen, when oxygen takes part in reaction, it becomes O2 minus. The meaning of O2 minus is oxygen has borrowed 2 electrons. So if I want to write the configuration of oxygen here at the ground state is 2,6. But at this state, when it's taking part in the reaction, it becomes 2,8. For fluorine, at the ground state, fluorine is 2,7. But when it takes part in reaction, after borrowing 1, F minus becomes F minus 2,8. I believe that is clear. Then group 5, kidnap 3 or throw away 5. Corporate begging for 3 or throw away 5, it's corporate begging. So these guys, they take part in reaction by begging. Begging, is it a positive action to beg or a negative action? It's a negative action. That is why they carry negative charge. So they borrow electrons or they beg for electrons, and then they become negatively charged. And that is what happens to non-metals. While metals, they give out, givers are positive, they become positively charged by giving out. And then group 8, they don't take part in reactions at all. They neither give out nor borrow. Why? Because they have attained octet valency and stability, and then every other element wants to be like them. Alright, so from this class, I want to believe that you understood everything that we discussed today. But before I leave, I want you to answer this question based on what we have done today. What is the family name? Is it an halogen? I'm talking about magnesium. Is it an halogen? Is it an alkali? Is it an alkali earth metal? I want you to go to the comment section and drop your answer there. Magnesium, what family does it belong to in the periodic table? And I'll be there to check up your response. Also, if you have gotten value from this video, go to the comment section and just type in value, 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 so that we can be encouraged to do more. And don't forget to share this video with your friends, post your comments, like this video, and if you have not subscribed to our channel, do well to subscribe to our channel and hit the notification bell so that you can be notified when we drop interesting content like this. Remember, on this channel we are committed to making sciences very easy for you: chemistry, physics, mathematics, and biology. Thank you for being a part of today's class. My name is Coach Paul. Look forward to seeing you in the next class. Bye for now.